Based on what we have seen so far, figuring out the inverse function is just flipping or switching the places, because one will take, let's say, as the original example, a 2 and turn it into a 5. That's your original function. The inverse function needs to be able to go back to the original value, turn it back into what it used to be. So if the inverse function takes a 5, it needs to produce a 2. So if you have function f represented by this graph, you have a series of coordinates that you actually know. So this coordinate is 8, 7. This point right here, that coordinate appears to be -5, 5. And the last coordinate appears to be -6, -3. So that means that in order to find the inverse function, if the original function has the points 8, 7, -5, 5, and finally -6, -3, the inverse function, let's try to use different colors, the inverse function will have to do the opposite. It needs to take in a 7 and give you back the original value. So just like Lupin turns into a werewolf, we need an antidote or some way of turning that werewolf back into Lupin. So this is in this direction, Lupin into a werewolf, and this is werewolf back into Lupin. So that's 5, -5, and -3, -6. If you plot those points, you will end up with a reflection of this graph over the line y = x. So let's see what happens. 7, 8. So that's 7, 8 right there. Then 5, -5. So 5, -5 right there. And -3, 6, -3, 6. Sorry, -3, -6 down there. So if you connect those points from here to here and from here to here, that will end up being a reflection of a line. If you sketch a line like this, over that line, that the line is y = x, they end up being a perfect reflection of each other. So that's how you sketch an inverse function based on the original function.